Alright, in this PowerPoint we're going to examine acceleration. Acceleration is something that happens all around. Now, we talked a little bit about just misconceptions we have, because I think a lot of times we think of acceleration and we think of speeding up. It's not necessarily speeding up, but rather acceleration is simply a change in velocity over time. So acceleration is a change in velocity over time. It is a vector, which means a size and direction do matter. Okay, and so we use the word a lot. If something's accelerating, we say, we think it's speeding up, but it could be speeding up. Let's get here. It says this could be speeding up, slowing down, or changing direction. All those are examples of acceleration, all of those are examples of acceleration occurring because, once again, it's a vector, so direction matters. And acceleration, by definition, is any change in velocity, speeding up or slowing down or turning. Velocity is, let's get distance over time, and in what direction. When a car speeds up, it has positive acceleration, so when the speed increases, the acceleration is going to be positive. And we'll look at that mathematically. When a car slows down, it has negative acceleration. All right, and I'm not going to use this word. All right, it's something we call it deceleration. Scientifically, though, it's negative acceleration is how we're going to look at it. And when a car turns, acceleration occurs also. All right, so our formula that we are going to use, to calculate acceleration. So A is acceleration. Now I'm just going to write down a few of these. So there's going to be a big V with a little subscript F. All right, just so you know what each of these means. There's going to be a V with a subscript I, a little subscript I. And what that means is the final velocity. Okay, so how fast it's going at the end. So when you see the velocity. This is the initial. How fast, initial just means how fast it's going at the beginning. So initial velocity. All right, and then you could look into, sometimes it's worded like this, where it has a T, which represents time, and the I and the F stay the same. So it's the same thing. So the final time minus the initial time. Basically the total time that is elapsed minus initial time. This is exciting watching me run. It's a good time. All right, and so what we want to do is we want to look at then the formula. So those are our variables, acceleration. Okay, so basically what we want to see is acceleration equals the final velocity, so how fast you're going at the end, minus the initial velocity all over the time. Sometimes it's worded like this, where it'll say, depending how you look at it, it'll have a triangle T, a change in time, so how much time has changed, so your final time minus your initial time, minus initial time. All right, so that is going to be our formula for when we solve for acceleration. All right, and since acceleration is a change in velocity over time, velocity is measured in meters per second. All right, so since velocity is meters per second, is measured in meters per second, time is measured in seconds. So therefore, our units, since it's velocity divided by time, which is seconds, our unit's going to be meters over seconds, which another way to write that is meters over seconds squared. All right, so every time when I ask you to put the units on, that's what it is. All right, so if we solve some of these, it would say, so we want to calculate positive acceleration. So I know it's going to be positive, so I'm going to write my formula down. Equals VF minus VI divided by how much time it takes. So here I know I'm starting at rest. All right, so once again, now you have to, when you get these word problems, it's helpful to write down your information just off to the side, just so you know. So it's starting at rest. So my initial speed is 0 meters per second. I end up, it accelerates to 80 meters per second, so that's my final velocity. And it takes 20 seconds. All right, so the change in time. So I'm going to do 80, my VF. Now I'm going to plug that into this formula. My VF minus my VI. So I'm 80 minus 0 divided by 20. So now my answer is going to be, so how much, and once again, this is how much meters per second squared, how much I am changing speeds every second. So as time goes on, each second that passes, this person, I don't remember, what is it, a motorcycle? This motorcycle is increasing its speed every second by 4 meters per second. So it's getting faster. It's increasing its speed by 4 meters per second every second. Maybe you guys do that one. On your notes. A skateboarder is traveling at, so the very first piece of information we have, so now we're looking at negative acceleration. A skateboarder is traveling at 3 meters per second. So once again, I'm just going to write down my information. What do I know? Well, I know my initial velocity is 3. I know he comes to a stop, so that means he brakes, or his velocity is 0. He comes to a stop, he brakes. That means he's going 0 at the end, and it takes 2 seconds. What is the skateboarder's acceleration? Well, once again, I know my formula. The final velocity minus the initial velocity all over 2. Now this is, or all over time, excuse me. The hardest thing to do is to see these numbers like this and plug them into the correct spot. That's why it's helpful, because a lot of times we see a number and we don't see a number, so we just instinctively want to go 3 minus 0. It's not. Make sure it goes in the right spot. 0 is my final. My initial is 3. So it'd be 0 minus 3 divided by 2 seconds. So then my acceleration is going to be negative, because 0 minus 3 is negative 3 divided by 2. So 0 minus 3, so it'll be negative 1.5 meters per second squared. And you can always check yourself when you're doing this, because if the skateboarder is traveling, if in the scenario I give you, if there is a person that is slowing down, stopping, if they've clearly slowed down or stopped, then that's going to be negative acceleration. All right, so you can easily go back and just check and just ask yourself, did the person speed up or slow down? If he slowed down, my answer needs to be negative. If this case, if I forgot to put the numbers in the right spot and I ask myself, did he speed up or slow down? Well, in this case, he obviously is slowing down. He comes to a stop. So if my answer was positive, I can easily fix that by just saying, oh, I messed that up. He obviously came to a stop. He must have slowed down. So therefore, it's a negative answer. So always just double check whatever scenario I give you. If the person or the car, or the object is speeding up, it's positive. If it's slowing down, it's negative. All right, so make sure you just always double check that. And we're going to look at speed time graphs as well. So a distance time graph, position time graph is the slope of the line. On a distance time graph, we're going to get a lot of practice at this, because this is where it gets a little bit confusing. This indicates a constant speed. All right, because remember, it's distance, rise over run is the thing, distance divided by time. Well, here now our y-axis is velocity, and our x-axis is time, so now it's velocity over time. Change in velocity over time is acceleration. So the slope of the line will tell you what the acceleration is. So an object moving horizontally on a speed time graph has a constant velocity. An object moving horizontally on once again, the slope is 0. Here, the slope is 0. It's a straight line. If the slope is 0, then there is no acceleration, because the slope equals the acceleration. Equals acceleration on a speed time graph or velocity time graph. All right. So if the slope is negative, the acceleration is negative. If it's a straight line, if there's no slope, there's no acceleration. All right. So we'll look at this more. I just want to at least introduce it.